Welcome to Club Academia. In this video, we're going to break down some of the fundamental building blocks of every electronic device, the components. From tiny resistors, capacitors, diodes, to powerful microchips, we'll explore how these little guys work together to create the tech we love. Whether you're an electronics enthusiast or just curious about how things work, you're in the right place. This video focuses on capacitor. What exactly is a capacitor? In simple terms, a capacitor is an electronic component that stores and releases electrical energy. Think of it as a small battery, but with some unique characteristics. A capacitor consists of two conductive plates separated by an insulating material called a dielectric. When you apply voltage across these plates, an electric field builds up and stores energy. When the voltage is removed, the capacitor can release this stored energy back into the circuit. Also, since schools and colleges aren't exactly teaching us how to build wealth, we have an announcement that Club Academia is teaming up with Wealth Talk to bring you the knowledge you need to succeed. Get ready for a financial education like never before. Learn about stocks, investing, money management, and so much more. Our goal is to empower you to take control of your financial future. Subscribe to the channel, Wealth Talk, for expert advice, tips, and strategies. Your journey to wealth starts now, and financial literacy is just as important, if not even more important, than academic literacy, which is why we want to give you the tools to start thinking about this as early as possible. Now, capacitors come in various types, each with its own strengths and applications. Let's look at some of the most common ones. 1. Ceramic capacitors. These are widely used and typically have a small size and low cost. They're great for filtering and bypassing high-frequency signals. 2. Electrolytic capacitors. These are larger and used for applications requiring higher capacitance. They're often found in power supplies and audio equipment. 3. Tantalum capacitors. Similar to electrolytic capacitors but more stable and with higher capacitance per volume. They're used in advanced electronics like smartphones and laptops. 4. Film capacitors. These use a thin plastic film as the dielectric and are known for their reliability and accuracy. They're often used in audio equipment and high-frequency applications. Let's talk about how capacitors are used in electrical circuits. Capacitors can perform various roles, such as smoothing out voltage fluctuations, filtering signals, and coupling or decoupling components. Capacitors play crucial roles in electronic circuits. They can be used to 1. Filter out unwanted noise. By blocking high-frequency signals, capacitors help to clean up the power supply. 2. Store energy. Capacitors can store energy temporarily, which is essential in devices like camera flashes or defibrillators. 3. Time circuits. Capacitors, in combination with resistors, can create timing circuits for applications like oscillators and timers. When a capacitor is connected to a power source, it charges up. This means it stores electrical energy. When the power source is removed, the capacitor can discharge this energy, providing a temporary current flow. To make things easier, let's use an analogy. Imagine a capacitor is like a water tank. The two plates are like the tank's walls, and the dielectric is the material that keeps the water from leaking out. When you fill the tank with water, you're adding energy. When you need water, you can release it quickly. In this analogy, the water represents electrical energy. Just as you can fill and empty the tank, a capacitor stores and releases electrical energy. When the circuit needs a burst of energy, the capacitor can provide it quickly, smoothing out power delivery. To measure capacitance, we use a unit called the farad F. However, due to the extremely small capacitance values in most electronic components, we commonly use microfarads MUF, nanofarads NF, or picofarads PF. To measure capacitance, you'll need a multimeter capable of measuring capacitance. Here's how. 1. Set the multimeter to capacitance mode. Look for the capacitance symbol, usually C or a capacitor icon. 2. Discharge the capacitor. Always discharge the capacitor before measuring to avoid damage to the multimeter. 3. Connect the multimeter probes, Connect the red and black probes to the capacitor's terminals. 4. Read the measurement. The multimeter will display the capacitance value in the appropriate unit, F, NF, or PF. So, in summary, capacitors are essential components in electronic circuits. They store electrical energy and release it when needed, and come in various types for different applications. Whether it's filtering signals or stabilizing power supplies, capacitors play a vital role in keeping our devices running smoothly. Thank you for tuning into this video. Take a moment to subscribe to Club Academia, as well as our financial literacy education partner Wealth Talk, which shares the tools and tips for smart financial planning.